So let's now consider the graph of the inverse sine function. So this is what the graph looks like over here. I'm just going to go through the basics with you first, and then through the next question we'll work through why it is. But let's just have a look at what this looks like first. So just remember, this is what your inverse sine function looks like. And the domain for your inverse sine is between 1 and -1. And your range is between pi on 2 and -pi on 2. Okay? So just remember that basic shape for me. Great. So now you know basically what the inverse sine function looks like and what the domain and range for that is. Let's have a look at how we got this. So in question 6a, we want to sketch a curve of the inverse of sine. Here we've already sketched for you the sine curve. Okay, so remember how it starts off here and we go like that? Yeah? So we have our y equals to x line, because remember it's always reflected in the y equals to x line that we have there. So if we reflect this, remember how I said it's hard to imagine it all together, so let's just consider the left hand side here. So if we flip that, that's going to look something like that, isn't it? Whereas when we flip the top half, that's going to look like that. So when we flip it all together, it's going to look like this, yeah? Whereas this portion is a flip of that, and that portion is flipped there, and it passes through the 0, 0 point there on the y equals to x line. So that's what the curve of the inverse of sine would look like. But now we want to find it so the inverse sine is also a function itself for the largest domain. So remember, something can only be a function if it satisfies a vertical line test. And you can see here, if I drew a line through there, it would cross that once, twice, 3 times. It would cross that twice there. So that's definitely not a function if we leave it like that. So we want to find the largest domain for which this is defined as a function. Okay, so perform the vertical line test. We draw all these vertical lines in, and you can see that the only 2 lines that crosses at once is going to be this line here and that line there, isn't it? Which means that it's only going to be defined as a function between that point and that point there. So rubbing everything else out, it leaves us with that curve. And that's the curve that I showed you on the first page for this, right? That curve there. That's how we get that curve. Can you see that? Now, let's consider the points on this curve. So this point here, so the very top of this curve is going to be pi on 2, 1, right? Because your sine curve goes up to pi on 2 and down, and this here is pi. So this is pi on 2, 1. Whereas this point here is going to be negative pi on 2, -1. Which means that when we want to find the domain, we're considering from here to here. So this point is just the flip of that. So it becomes 1 pi on 2. So this point here becomes 1 pi on 2. Whereas this point here becomes -1, -pi on 2, like that. So that's why you can say the domain of this is going to go from the x values of 1 to -1, isn't it? So that's why our domain is going to be greater or equal to -1 or less or equal to 1 there. All right, so if we know all of this, let's find the largest range of this so it's also a function. So the range, because we've already flipped the values, you can see it's going to just go from pi on 2 to -pi on 2, isn't it? So our range is what's defined here. So now can you see how that's how we have this curve here? And because this point is reflected in this line, so we flip the x and y values, that's how we get the domain and range for our inverse sine curve. So I think now that you know this, if you do ever just have a blank moment in the exam, at least there is a way that you can work it out. It's better than just memorizing something. It's always easier once you understand why a concept has come to be. Okay, let's move on now. So here in question 7, we've been given this function of y equals to 2 times the inverse sine of 2x plus 1. And we've been asked to find the domain and then the range of this. So what we want to explore here is when we alter the function of inverse sine, what happens to the domain and range. And before we do that, let's go back and have a look at the original inverse function. So this is a curve. And remember, the domain of the original was between 1 and -1, and the range was between pi on 2 and -pi on 2. Now, I want you to consider that this x here is the input for inverse sine, right? We're putting that into inverse sine to work out our output. So, if the input here is between 1 and -1, then our input here must also be the same. So this is our new input. So that has to also be between -1 and 1, right? So now all we need to do is get rid of the other things around x to find out the domain. So subtracting 1 from both sides, it's going to be between -2 and 0. And now dividing both sides by 2, you can see that x must be between -1 and 0. So therefore, this function is only defined for the domain between -1 and 0 there. So remember, to work out the domain, what we're considering is the input for inverse sine, which must be between -1 and 1. Is that easy enough? Good. So now we've considered how to work out the domain. Let's consider how to work out the range of this function over here. So when we're working out the range, what we need to consider is the output of the inverse function. So if this is the input, we put that into the inverse and that gives us the output. But we can also consider, since y equals to this, that this whole thing here is our output as well, right? Because this is our output, but since that equals to that, this is our output. So that's going to be between pi on 2 and -pi on 2. Now, if that's our output there, the new output here is only this portion, okay? Because we're putting this input into the inverse sine. So the inverse sine of that is our output. But it doesn't include the 2 or plus 2 or whatever they add onto it, because that's just numbers that alters the output. But this is our output itself. So that portion there must be between -pi on 2 and pi on 2. And what we want to do is alter this to look like that, which you can see, well, we just need to multiply that by 2, right? So you just multiply everything by 2. And that leaves us with, this must be between -pi and pi, which we've drawn over here, okay? So just to revise, when we want to work out the domain, we considered the input, which is just what's in the brackets there. And we want to work out the range, we want to consider the output of inverse sine. So that's just inverse sine of that. And then we need to multiply or add things to that to work out what the range is. All right, so this is what the domain and range for this function is. So knowing that, how are we going to sketch this function? So remember, it's defined for this, which means that we want to essentially sketch it in that region there, isn't it? So if this is what the curve should look like in that region, what do you think it's going to look like in this region here? Well, it's just going to be this, but stretched more, isn't it? So that's going to look like that. Can you see how this is just this, but stretched longer because the region is different now. So that's how we've drawn this function here, just by finding out the domain and then the range first, and then just slightly stretching the inverse function of the sine curve to fit the new domain and range. Okay? All right, so this is where we learned how to find out the domain and range when we change the function of the inverse of sine. So in question 8, we've been given the new function of y equals to the inverse sine of negative x plus 0.5 plus 1. So here we're going to be doing similarly what we did in the previous question. Okay, so just going to be practicing those rules. So we want to find the domain of this. So remember, to find the domain, what we want to do is consider the input of the inverse sine. So the input is going to be what in this case? That's right, it's going to be this portion over here, isn't it? Because that's the input for the inverse sine. So that must be between -1 and 1. Okay, so here we just want to subtract 0.5 from both sides. So it's going to be between -1.5 and 0.5 here. Now, importantly, can you see how this is a negative x? So to get rid of that negative, I need to multiply everything by -1. So this will become 1.5 and this will become -0.5, and the signs will have to change for that as well. Okay? Now for this negative x, I want you to keep that in mind, because that negative means that when we graph it, we need to flip it over. Yeah, so this curve must be flipped over if there is a negative x. So let's keep that in mind for when we need to sketch it. So that's the domain, we've done that. Now let's find the range for this function. So remember, the range was the output of the inverse sine. So in this case, the output is going to be this part here. Yeah? So the input into the inverse sine gives us the output. And this is just numbers that's added onto the output, but not part of the output. So the output has to be between pi and -pi/2 there. And because there's an added 1 there, that means we have to add 1 onto everything. So essentially what we want to do is make the output here look exactly the same as y. So adding 1 to that, that's going to look exactly the same as y, so we can just write y, and that becomes 1 minus pi/2, 1 plus pi/2. So this is our range, which we have sketched over here. Okay? So now we've found out our domain and range by respectively using the input and then the output. Let's consider what the sketch of this function is going to look like. So remember, it has to lie within the region of the domain and range. So it has to be in this region, okay? The other thing was that it's a negative x, okay? Which means we want to flip the curve. So instead of it being like that, it's going to be the other way around. So I want you to quickly have a go of what you think that's going to look like. All right, I'll give you a couple of seconds. Okay. All right, did it look anything like this? Well, that's really good, because what we've done, we've just flipped it, and we know it has to be between that region there. Yeah? So just remember, if you have negative x, even though with your domain you can't quite tell, you always have to check that for negative x, we must always flip the curve when we sketch it.